Okay, operations in with matrices. Main thing to remember is when you're adding and subtracting matrices, you have to have the same dimensions of matrix. So you can add a 2 by 2 like this first one. 2 by 2 matrices like this first one because they have the same number of rows and same number of columns. And you just add element by element wise. So like you do this position plus this position gives you this position. So this one as an example would be 3, 3, negative 3, 5. However, something like this where we're adding a 2 by 2 and a 3 by 3 does not exist because they're not the same size matrices. And then when you can multiply a scalar times a matrix, this is called scalar multiplication, and you just multiply 5 times each member of the matrix. So this would be 5, 20, 10, 15, 0, 25, negative 10, 5, and 20. All right, let me just show you an example of matrix multiplication and how that works. The main thing to remember is if we're multiplying a matrix A, that is an M by N matrix, in order for the matrix multiplication to work, B has to be an N by P matrix, and the result will be a matrix that is M by P. So in other words, if we look at the M for A being M being the number of rows and N being the number of columns, B being an N by P, where N is the number of rows and P is the number of columns, the number of columns of A needs to be the same as the number of rows of B. And the result will have the same number of rows as A does and the same number of columns as B does. So for example, let's take a 2 by 3 matrix A, and so this is a 2 by 3 matrix. So think about, in order for a matrix B to be able to multiply, it's going to have the same number of rows as as A has columns. And so maybe we'll do a 3 by 2. So it might be something like 7, 1, 0, 2, 3, negative 4. Okay, and so this would be possible because, like I said, we have a 2 by 3 here and a 3 by 2 here. And the result is going to be a 2 by 2 matrix. Now I'll just say, okay, this is our let's call this one A sub 1 1. I guess we shouldn't call it A. I guess we should call it C. So we'll do C sub 1 1, C sub 1 2, C sub 2 1, and C sub 2 2. And the way that we find C sub 1 1 is we're going to take the first row of A, and we're going to find the dot product with the first column of B. And so that's why labeling the 1 1. So it's the first row, first column. And what we do is we say 3 times 7 plus 1 times 0 plus 2 times 5. And so that gives us 21 plus 0 plus 10. That's 31. Now for the first row, second column element, we take the first row and we're going to find the dot product with the second column. So the first row of A and the second column of B, and that's going to be 3 times 1 plus 1 times 2 plus 2 times negative 4. So we get 3 plus 2 plus negative 8 gives us negative 3. And then the C2, 1, so the 2, 1, second row, first column. 2, 1, second row, first column. And then we do negative 1 times 7 plus 4 times 0 plus 5 times 3. So negative 7 plus 0 plus 15 is 8. And then C22 would be, and this would be our second row, second column, we get negative 1 plus 8 is 7, plus 5 times negative 4 is negative 20, and so that would be negative 13. So our resulting matrix is 31, negative 3, 8, and negative 13. And again, remember, you don't matrix multiplication doesn't always exist, and it's not even necessarily the same size matrices can be multiplied together, but they have to follow the rule where the number of columns of the first matrix has to equal the number of rows of the second matrix.